So, we will discuss bonding in solids in this class. So, there are mainly 5 types of bonding are found in solid crystal. So, they are ionic bonding, then covalent bonding, metallic bonding, then fourth is hydrogen bonding, and fifth is van der Waals bonding, or it is also called molecular bonding, molecular bonding, right. So, if you are familiar with this most of the bonding. So, this when it forms molecule, so this it formed due to the ionic bonding, covalent bonding. So, that is you are familiar with this, but I will discuss what are those bonding as well as in which materials we see such bonding, and that we will find out. So, this example of ionic bonding in solids. So, this thing sodium chloride, potassium chloride, also cesium chloride. So, all alkali halides and alkaline oxide, say copper oxide. Okay. So, this we can tell that all alkali halides lithium, alkali atoms are lithium, sodium, potassium, these are alkali atom. Halides, this your fluorine, chlorine, iodine, right. So, all halides and this alkaline oxide materials generally have this ionic character, ionic bonding. Okay. So, this and covalent bonding, where we find out covalent bonding. Covalent bonding, you can this in diamond carbon, basically in diamond form, silicon, germanium, right, germanium, gallium arsenide. Okay. In this material we see this covalent bonding. Okay. And then metallic bonding, we see this in metal. So, this it can be gold, silver, copper, right, this sodium material, sodium solid. So, these solids are made because of this metallic bonding. And hydrogen bonding, so this nice example of this bonding one can see in ice formation, and this van der Waals bonding, it generally seen this inert gas So, at low temperature inert gas forms the solid. Okay. So, there the solid is formed because of this van der Waals force, van der Waals bonding or this molecular bonding. So, this basically your this inert gas neon, argon, right, helium. So, these are the inert gas. So, when this inert gas forms solid at low temperature, so this solid, these atoms are held in solids because of this molecular bonding or van der Waals bonding. So, I will discuss one by one. So, ionic bonding. What is ionic bonding? Basically, bonds between two ions, one is positive ions and another is this negative ions. So, like sodium chloride is a classic example. If sodium atom and this chlorine atom, they come closer, then sodium leaves one electron or gives one electron to chlorine, right. So, sodium lose one electron and chlorine gain one electron. So, this sodium now is a positive ion and chlorine is a negative ion, right. So, why the sodium want to give one electron and chlorine want to accept one electron? So, that is because of electronic configuration of these atoms. So, you know, for sodium, this how many electrons are there? These 11 electrons are there. So, electronic configuration is 1s2, 2s2, 2p6, 3s1, right. And chlorine is having how many electrons? 17 electrons. So, its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p, 3s2, 3p, 5. So, this 4, 10 and 5 plus 2, 17. Okay. So, you know that electron, this inert gas, electronic configuration of inert gas, that is the preferable configuration, stable configuration. There is no valence electron, okay. All are core electron. So, inert gas or So, helium has 2 atom, 2 electron, right. So, this 1s2. So, its cell is filled, right. Similarly, for neon 10 electron. So, 1s2, then next cell is 2s2 2p6. Okay. So, outer cell is filled, outer cell is filled, outer cell is filled. So, for neon, the sodium, it has 11 electron. So, if it leaves this electron, so this so then it will get this configuration of this neon inert gas configuration. Okay. So, in outermost cell is 8 electrons are there. Okay. So, it is sometimes called octet rule also, So, this so it will be more stable if it leaves 1 electron, and for this chlorine, so this is configuration of chlorine and this is configuration of sodium, and here if so 1s2, 2s2, 2p6, 3s2, 3p6, if it 3p6, then it will get next inert gas configuration, that is basically argon, So, argon is 1s2, so here 1s2, 2s2, 2p6, 3s2, 3p6, right. So, this 10 and this 8, sorry, 2 to 4 are 6, 4, 6, 10 and this 18. So, this basically 18 electron, this is 10, this is 2. Okay. So, again here in outermost cell 8 electrons. Okay. So, it will if any atom gets this configuration, so it is the stable configuration. So, this chlorine will go in this configuration if it takes 1 more electron. So, it will accept 1 electron, so then it is this, it will leave this electron. Okay. So, there is exchange of electrons between these two, sodium is giving and chlorine is taking. So, thus they form, they are exchanging between them something. So, that's the basically they form bonding between them. So, that's the called ionic bonding. Okay. So, so that means all alkali atom, if it leaves 1 electron, it gets stable configuration, atomic configuration, and all halide atom, so that is chlorine, fluorine, iodine. So, this atom, if they accept 1 electron, so they will be stable, electron configuration will be stable configuration. So, wherever they will get chance to give electron and to take electron, so they will prefer that environment. So, this is the reason that when many atoms not one sodium atom, one chlorine atom. If many sodium atoms and many chlorine atoms, if they put together, so they will form solid, they will form solid. So, they will form solid. Okay. Okay. So, they will arrange themselves in such a way, they will arrange themselves in such a way. So, etc., etc. Okay. So, they will arrange themselves in such a way that they can form ionic bonding, they can hold each other, exchanging the electrons, just donating electron by one atom and accepting that electron by the another atom. Okay. So, this in case of sodium chloride, this is the, so this is the picture where two types of electrons are atoms are there. One of them are prefer to donate one electron and another one is prefer to accept that electron. So, thus they will form basically, bonding and hold each other. Okay. So, that is why the solids of alkali halides, alkaline oxides. So, alkaline they are basically they can they have two, they can leave two electron, and oxide oxygen it can accept two electrons. Okay. So, ionic crystal ionic bonding we will see that you need these two different type of atom. One will leave electron as many as it will leave. So, we need the acceptor. So, there should be another type of atom which can accept them. Okay. So, only then they will form crystal due to this ionic bonding. Okay. So, so this basically because of this bonding, atoms are held in the crystal, but how they will arrange that configuration, it depends that the total energy of the system, total potentiality of the system has to be minimum. So, when I have shown you that the total potential energy of the system has to be minimum. That potential graph I have shown earlier, right. So, this is for between two atoms. Okay. So, you have many atoms. So, from one to other. So, there is they have to accommodate, or they have to find the configure in such a way that total energy will be minimum, and that is nature prefers. So, that way automatically that is self organization of these atoms in a structure such that the total potential energy will be minimum. So, during calculation of this potential energy, you remember that I told that this force. So, basically relation between this potential energy and force that we have seen. So, due to electrostatic force, two types, one is repulsive force and the attractive force. So, balancing between these two force, okay, will give the zero, when that force will be 0, at that 0 force basically this potential become minimum. Okay. So, that will be taken as a minimum that equilibrium position from between these two atoms. So, here in general that we told that balancing between the repulsive force and attractive force, right. So, we have to find out that what is the origin of this repulsive force and attractive force. So, that should be there, then only we will get the equilibrium distribution of atoms in the solids. Okay. So, in this crystal obviously we have positive ions and negative ions. So, repulsive force between positive and negative and attractive force between these opposite ions sodium and chlorine. Okay. So, this is the origin of this electrostatic force which will hold the atoms in a crystal. So, in this ionic crystal these are obvious, there are electrostatic force in this system. Okay. So, next I will discuss this then covalent bonding. Covalent bonding. So, example this basically carbon, silicon, germanium, right, gallium arsenide. Okay. So, these are the materials where we see that covalent bonding is responsible for the formation of the solids crystal, right. So, what is covalent bonding? What is covalent bonding? That you know that the sharing of the electron between two atoms, right. So, basically if you take H2, the hydrogen gas, right. So, 2H, so 2 atom hydrogen atom, if they come close, okay, they can form hydrogen molecule. So, this basically hydrogen gas H2, right. Why they form, how they form? So, there must be some bonding between these two. So, that bonding is basically this is having 1 electron, this is having 1 electron, right. So, 1 S1, 1 S1, right. So, if because the stable configuration is 1 S2, so to have that one, so this hydrogen it will prefer to have 1 electron, right, 1 electron, and this other one also will prefer to have 1 electron. Okay. So, what they do, they just this hydrogen just give 1 electron, this hydrogen gives 1 electron. So, 2 electron is kept in middle between these two atom, okay, as if so this. So, this hydrogen is as if it is sharing these 2 electron and this also sharing this 2 electron. Okay. So, thus they are filling the stable configuration, helium configuration H2 He this for 2. So, this having 1s2, this is the inert gas stable configuration. So, they are having this similar to this configuration as if. So, they feel more stable than this individual hydrogen atom. So, thus they prefer to form this H2. So, instead of staying this as a hydrogen atom, they prefer to stay as a hydrogen molecule H2. Okay. So, this type of bonding which is holding these 2 hydrogen together. So, this is the covalent bonding. Okay. So, this is the example of covalent bonding. So, now I am telling this carbon, silicon, germanium, gallium arsenide, they are the crystal where covalent bonding is responsible for holding the material. So, basically then we have to show that there is a sharing of the electron among the atoms. So, let us say carbon, how many electrons are there? I think 6 electron, carbon 6 electron. So, this so electronic configuration 1s2, 2s2, 2p2, okay, 2p2. So, here basically 2s and 2p, their energy are almost same, it is very close. So, these two basically, so this electron, so 2s2 and 2p2 instead of 2s1 and 2p3, okay. So, it can take that configuration also. So, then we tell that this sp3, sp, so 1s electron and this p 3 electron. So, its sp hybridization, it form sp hybridization. So, this s1 electron, p3 electron, sp3 hybridization, okay. So, then basically this 4 electron will have this equivalent energy level. So, this sp3 hybridization, okay. So, they are equivalent, okay, but they are directional, So, as if the sp3, so this equivalent 4 electrons are there, okay. Now, if 2 carbon atoms come closer, okay, as a octet rule, so they prefer to have this 8 electron, okay. So, in sp3 hybridization they have 4 electrons, so they will try to have more 4 electrons, okay. Then they will feel more this comfortable or this stable configuration. So, this carbon have 4 sp3 hybridization, this and this other one also. So, they will prefer to, so each carbon atom will prefer to share with these 4 carbon atom. So, from each one electron, it has 4 electron outside orbits, okay, and 4 from these 4. So, they will get this, so they as if they are sharing, okay. So, it has 4 electrons, so it is sharing with 4 carbon. So, then this it will fill to that 8 electrons. So, this basically the sharing, so these are the this bonding is basically covalent nature, covalent bonding. So, in this material, so carbon, silicon, germanium, so they are because of this covalent bonding, the crystal are formed, okay. So, then again this so this again this carbon will hold again one here and with other 3. So, this the chain will go on and it will form the solid crystal, right. So, similarly metallic bonding, so metallic atoms, as I mentioned, silver, gold, sodium, etc. So, all this metal outside electrons are there, valence electron. either one. So, in case of sodium, this outside there is 1 electron. So, I think silver, the one has to see electronic configuration. So, if it leaves outside electron, in case of sodium say, so 11 electron, if it leaves 1 electron, so it gets stable configuration. So, this basically sodium ion plus, and this it leaves 1 electron. So, thus many sodium comes together, sodium atoms comes together. So, they fail to leave 1 electron, they fail to leave 1 electron. Okay. So, they fail to leave 1 electron. Okay. So, basically what this electron does, so it forms the core of ions, sodium ions, and this all electrons is not it's not attached with this sodium ions all the time, as if it just moving, they are moving around the all ions, they are moving around the all ions. Okay. So, basically you will see this electron C and the positive ions core. Okay. So, overall these positive ions and these electrons, they are so it is not electron for a particular ion. So, overall this all electrons sharing with all these sodium ions, positive ions. So, this type of bonding, so they hold this type of sharing of the electron C with this whole core of ions. So, this type of bonding, holding is basically metallic bonding. Okay. So, for this also we tell this free electron gas. So, this type of property material shows the electrical property, conductive property. So, that we will discuss when we will learn this electrical property of the material. So, these are metallic bonding. So, this type of bonding holds the these materials in solid form. So, similarly this, so these three, this mainly all in most of the solids we see this type of bonding. So, these are called primary bonding, and these other two are there. So, these are basically it's called secondary bonding. So, this hydrogen bonding, right, hydrogen bonding. So, that is it is seen in as I told inert gas, no, it is seen in this ice in case of ice. So, this H molecule is forming, it is not hydrogen bonding. Okay. So, it is here it is covalent bonding. So, hydrogen bonding is basically different. So, it helps to bond with other two atoms. Okay. So, hydrogen helps to bond with other two atoms. This is ice. So, basically water, no. So, oxygen and this. So, so oxygen if it gets 2 electrons, so it will get stable configuration, and if it leaves 1 electron, it will get a stable configuration. So, okay. So, so it gives 2 electrons, okay, shared with, sorry. So, yeah. So, it has 1 electron, and oxygen have, I think it is 8. Okay. So, if it have this 2 electron, so this thus they share electron, oxygen share electron with hydrogen, 2 hydrogen, or 2 hydrogen share electron with oxygen. So, it basically forms a dipole, is permanent dipole. So, now when there are so there are many water molecules together. So, they form basically the, So, due to this dipole-dipole interactions, okay, so they will hold each other because of this dipole-dipole interaction. So, this type of bonding, holding, and this will happen through the hydrogen, and this type of bonding is basically it's called hydrogen bonding. And last one, this van der Waals bonding. Van der Waals bonding. So, that is argon gas, neon gas, it is inert gas, basically when at low temperature they form of the crystal. So, here this argon atom are stable, right, but when they come together, so why they will, how these atoms will be hold together. So, that is we are telling this because of van der Waals bonding, so or molecular bonding, it is tell also molecular bonding. So, they hold each other. What is that? So, basically these are neutral, fine. So, it is a stable configuration, but when another similar atom, same atom are coming closer, okay. So, then basically here arrangement of the charge is disturbed, okay. Arrangement of the charge disturbed because of this other atom coming closer to it. So, that is the basically it is so it will form this whatever it has positive charge and surrounding this electronic. So, they are now disturbed. So, it will form a temporary dipole moment, okay. So, each one will form a temporary dipole moment because of the just distortion of this atom, distribution of the ions charge, ionic charge, okay. So, each will behave as a temporary dipole. So, now this is the source of electrostatic force, dipole-dipole interaction. This type of bonding, holding of these inert atoms, these are very weak, and that is this type of interaction is called van der Waals interaction, van der Waals force, okay. And holding these things in together in a solids, of course, here at low temperature, that is the that is called van der Waals bonding or molecular bonding, okay. So, this is the about the different kind of bonding or interaction among atoms, okay, which are responsible for the for formation of the solids. So, I will stop here. Thank you.